Hello again everyone and welcome back to the Fusion Industry Association. My name is Jasmine Mund. I'm a mechanical design engineer with a key interest in the fusion industry. Today is Wednesday the 30th of October 2024 and I'm here to give you your fusion news update this week. And now onto the key headlines for today's episode. 1. Tokamak Energy gives details of pilot fusion energy plant design. 2. Thales and the Max Planck Institute for Plasma Physics set a world record in the field of nuclear fusion. 3. For heating plasma in fusion devices, researchers unravel how electrons respond to neutral beam injection. 4. Nuclear fusion push. General Atomics releases fuse to speed up reactor development. 5. US Department of Energy announces nearly $30 million for 13 projects to enable commercial fusion energy. And make sure you stay till the end because, as usual, I have quite a few interesting bonus stories that you might want to check out. 1. Tokamak Energy gives details of pilot fusion energy plant design. The first story today comes from World Nuclear News about FIA member Tokamak Energy. TE, a UK-based company, has shared the first details of its pilot fusion energy plant, designed to be a part of the USA's bold decadal vision for commercial fusion energy. This high-field spherical tokamak is expected to generate 800 megawatts of fusion power and produce 85 megawatts of net electricity. The company aims for the plant to be operational by the mid-2030s, contributing to the development of clean, carbon-free energy. Unveiled at the American Physical Society's Division of Plasma Physics meeting, the plant's design features an aspect ratio of 2.0, a plasma major radius of 4.25 meters, and a 4.25 Tesla magnetic field. It will also include a liquid lithium tritium breeding blanket and a new generation of high-temperature superconducting magnets. These magnets are critical for confining and controlling deuterium and tritium fuel in a plasma that will reach temperatures far hotter than the core of the Sun. Discussing their role in this bold decadal vision, Tokamak Energy President Michael Ginsberg said, "We are delighted by the reception from an expert crowd and energized on our mission to demonstrate net power from this pilot plant in the mid-2030s, paving the way for globally deployable carbon-free fusion energy." With its strong links to US national laboratories and its participation in the Department of Energy's milestone-based fusion development program, Tokamak Energy is positioning itself as a leader in the race to develop commercially viable fusion energy. 2. Thales and the Max Planck Institute for Plasma Physics set a world record in the field of nuclear fusion. Next up is the news from Thales about their collaboration with the Max Planck Institute for Plasma Physics and the major milestone achieved in the Wendelstein 7X Stellarator project with its TH-150-7E gyrotron. This advanced device reached a total output of 1.3 megawatts in radio frequency at 140 gigahertz for 360 seconds. The gyrotron plays a crucial role in heating and stabilizing the plasma within the stellarator, helping achieve the extreme temperatures required for magnetic confinement fusion. The Wendelstein 7X project aims to deepen the scientific understanding of plasma physics while advancing the development of commercial fusion technology, which could provide a clean, sustainable energy source. Fusion energy, seen as a critical solution for reducing global carbon emissions, does not produce greenhouse gases and relies on resources that are abundantly available in nature. As a result, it holds great potential to address both the growing demand for energy across sectors like transportation, construction, and agriculture, as well as the urgent need to cut carbon emissions. Charles-Antoine Goffin, Vice President of the Microwave and Imaging Subsystems at Thales, stated, "This technological breakthrough positions Thales at the forefront of high-power plasma heating solutions, essential for addressing the energy challenges of tomorrow." 3. For heating plasma in fusion devices, researchers unravel how electrons respond to neutral beam injection. Our third story today is from the US Department of Energy. Researchers at the D3D National Fusion Facility have made significant progress in understanding how electrons in fusion devices respond to neutral beam injection, or NBI, which is a common method used to heat plasma. As part of a graduate student project, the team closely monitored changes in electron temperature during NBI and explored the physics behind these changes. By comparing their observations with Monte Carlo simulations, they discovered that the trajectory of the electron temperature curve is influenced by the competing effects of fast ions and cold electrons, which are produced when neutral particles are injected into the plasma. This insight is important because the electron temperature curve can be used to deduce the neutral beam deposition profile, providing a way to experimentally monitor the performance of the neutral beam. Accurate monitoring is crucial for validating or refining models that predict the transport behaviour of plasma electrons and fast ions, which are key factors in achieving the conditions needed for sustained fusion. This research not only enhances understanding of plasma behaviour under MBI, but also offers a practical tool for improving the accuracy of fusion experiments, which is critical as scientists work towards making fusion energy a viable and efficient source of clean energy. 4. Nuclear fusion push. General Atomics releases Fuse to speed up reactor development. Next up, we have a story from General Atomics, which has introduced the Fusion Synthesis Engine, or Fuse, which is a new open source software platform designed to accelerate the development of fusion technology. Fuse integrates essential aspects of fusion research, including plasma physics, engineering, and cost analysis, allowing advanced simulations to be conducted on standard computers without the need for extensive equipment. By making the software available under the Apache 2.0 license, General Atomics has ensured that it can be freely used, modified, and commercialized by researchers worldwide. Wayne Solomon, Vice President of Magnetic Fusion Energy at General Atomics, called the release a bold and exciting step that offers a powerful tool to the entire fusion community. One of the major obstacles in fusion research is developing designs capable of withstanding the extreme conditions required for sustained fusion reactions. Fuse aims to address this by enabling faster, more accurate simulations of fusion operations, with built-in machine learning to improve designs and reduce uncertainties. One of its strengths is that it uses machine learning to speed up simulations. The release of Fuse comes amid a global push in fusion research, with major projects like the UK's MAST-U upgrade and Spain's Small Aspect Ratio Tokamak, SMART, moving forward. Fuse is expected to foster great collaboration and innovation. 5. US Department of Energy announces nearly $30 million for 13 projects to enable commercial fusion energy. Last but not least, we have news from ARPA-E, the Advanced Research Project Agency for Energy. About 13 projects have been selected to develop advanced materials and technologies for fusion power plants, receiving significant funding through ARPA-E. These projects focus on addressing key challenges in creating durable, efficient fusion technology. Of note, FIA member Exo Fusion is working on a new liquid material for fusion first walls, designed to continuously replenish the wall material in harsh environments. Texas A&M Engineering Experiment Station will use machine learning to speed up material discovery, screening hundreds of material compositions per day for fusion power plant applications. The University of Kentucky aims to improve porous tungsten alloys by infiltrating them with ceramics to increase thermal conductivity and irradiation resistance. Other projects include the development of advanced coatings, thermal management systems, and novel alloys, each designed to withstand the extreme conditions within fusion plants. The projects are part of a broader push by ARPA-E to advance clean energy technologies, ensuring the US remains at the forefront of global fusion energy development. And now, as promised, here are the bonuses. First up, I have an article looking at the development of fusion technology in Spain and New Zealand. Next, I have a bonus from Innovation News Network, looking at how fusion could help achieving global decarbonisation once the technology is commercialised. I also have a couple of more technical articles, one about an efficient way to optimise laser-driven fusion, and one about recent updates to MAST-U, the UKAEA's mega-amp spherical tokamak upgrade facility. And finally, I have 2 bonus articles from Interesting Engineering. The first is titled, How Nuclear Fusion Study Helps Cut Turbulence, Boost Plasma Thruster Power, about how fusion could be used to improve space travel in the future. The second is about ATLAS, or Advanced Technology Lasers for Applications and Science Facility, a powerful new laser research facility located on Colorado State University's Foothill campus. And that's it for today. I really hope you enjoyed today's episode. If you did, don't forget to drop a like, comment, or subscribe. If you'd like to know more about any of the stories or the bonuses mentioned in today's episode, as always, the links will be in the description below, and you can follow our Fusion News Extra podcast for a more in-depth look into the topic of fusion energy. Thank you for watching. I'll see you next time.